Okay, good day and welcome to another training session. So we're going to continue from where we stop. So this is lesson two. We we finished lesson one. So we're going to continue lesson two. So lesson two, we're talking about installing system devices. So which is hardware. So remember this course is CompTIA A plus core one exam 21001. So if you are planning to take the A plus exam, this is your this channel is your best channel, is the best place to come to prepare for the exam. So I want to assure you that if you follow all our trainings, all our teachings to the end of the whole of this program, you can confidently sit down, take take some past questions, after which you can go for the exam. Okay. Okay. So what are our objectives? What are our objectives? Now, our objectives are first of all, we look how we can install and configure power supplies and cooling. Select and install storage devices. We talk about this in lesson one. Install and configure system memory. Install and configure CPUs, central processing units. Okay, so this is 2A, installing and configuring power supplies and cooling. Okay, here we go. So yeah, take a look now. So from From our lesson one, we showed you about the system casing. We showed you about the system casing, but we explained different type of power supplies, right? Okay. We talk about the ATX power supply and the ITX power supply. And we said the ATX power supply are the most commonly used power supply. Now, this is a typical example of the ATX power supply. You see power supply units, right? Okay, so now we have to understand that the ACs, the power supply itself is what supply power to our motherboard, you know, and the motherboard, we said, is what other hardware, other components are connected to. So we explain the motherboard in lesson one. If you don't listen to our lesson one, please kindly go there and listen to lesson one, right? Go to our channel, look at lesson one. We explain about the motherboard. Okay. So inside the motherboard, we need to provide power supply, which we call DC, right? Direct voltage. So those components so that they can function effectively. Now, the power supply need to get an AC, right? Which is the voltage that you get from the power supply, alternating current. That's the voltage that comes with direct current, that comes from the wall. So we should also connect here, so you have to connect it here. So we call it AC. So this voltage is based on the location you are. If you're in the UK, it's between 220 to 240, right? Same with what if you're in UK, yes. If you're in the US, they have the lower line, which is 100 to 127 voltage, right? So these are the inputs. So we have input of AC, which is give us from US. Those countries in US they use between 100 and 127 and 127. Then from Africa countries, those in the Africa countries, Nigeria, the UK, and some other European countries, they use the voltage of 220 to 240, which is called high line. Now, some of this power supply they have at the back of it, they have a two input votes. So which means you will see 110, I could see 220. So that means they could take both the voltage for the US and go for the UK. Remember, I just said the US is a low line, is between 100 to 127, and the UK use the high line, which is what 220, 240. So you could have a power supply that can contain both. right? So what do you do? At the back of the power supply, you can see there's an auto switching at the back. There you can, if you want, if for instance you're in the UK, then you can check your at the back. You see the power rating is showing 220. If it's showing 220, you don't need to do auto switching. Just leave it, right? Just leave it like that, right? Now, if you move to the US, for instance, and you see your voltage is showing 220, before you connect to the power, before you connect to the power source, what you have to do is to switch the button, to you switch from the button to 110 for the US, right? So that was the amount of auto switching fixed power supply unit. So that's so like this now. You see, this one now is automatic. There's no switch at the back of it right now. So that means if you are buying the power supply, you must check the voltage regulator at the back of it. Check at the back of it is written. So the manufacturer must have written the power rating there. So if it's US, you're going to see 220 US. If it's US, you're going to see 110, 110. If it's UK, you're going to see 220. That's why the power supply is, if the power rating is showing 220, it means it's a UK. So you can buy it and use it, right? But if you're seeing auto switching, if you're seeing a, a switch at the back of it that's showing 220, I say a switch means you can switch to what between 110 or 220. So remember, if you are in US, you have to switch to you have to be 110 to 127. If you're in UK, you have to be between what 220 to 240. Okay. So here we go now. So here we can see some of the voltage power requirements. So we have volts, we call it which is direct current. Then we have the watts voltage. V stand for the current. V stand for voltage. I stand for what? Current. So these are electrical symbols. So when you see V, it's about voltage. So voltage are what goes inside the computer itself. So that what goes to the computer. The current is what comes in, which is the input. The voltage is what goes into those components, right? So the power supply receives current, right? Then those currents are being converted. Those currents called AC, which is alternating current. So that current it goes to the power supply, is being converted, by the power supply to voltage, which all the components uses, right? Okay. So power voltage output. So you can see the voltage output that comes out between 3.3 volts, 5 volts, 12 volts phase. So these are some of the power rating that you're going to see. Right? Okay. Now, take a look now. Now, your power supply has this kind of connectors. You see, has this pin like this, which you're going to as a connector. See, have some that your power supply have this. So again, I mean, when we explain lesson one, we explain the connectors. You know, SATA connectors, the power supply, we explain all these ones. So again, I would advise you to look at lesson one, look at it and spend time because that's the foundation so that you can understand better. So this is power supply. So this is the power connectors, So P1 is power supply, P11 is the connector. So you have 20 pin and 24 pin, right? So you have the adapters and on, right? Okay. So now the next thing is the cooling fan. The cooling fan. So the cooling fan are usually the fan that are connected to what the CPU. Again, when we talk about lesson one, we talk about the CPU. I'll talk about the CPU socket, which it is. We told you how to fix it, how to connect the CPU socket. All right. Now, first, let's see why the heat sink. Now, the heat sink work actually is to observe the heat that comes up on the CPU. Because the CPU, what it does to process. And since the CPU works to process information, thousands and millions and billions of information at the same time. So in most cases, the CPU is or that the process is always very hot. So when there's no heat sink to absorb the heat coming up from the CPU, there's no heat sink. So there is tendency that the process might get burnt. And if you get burnt, it must affect the motherboard, and that will be the end of the motherboard. So the work of the process of the fan of the heat sink there is to first of all absorb the heat coming out from the processor. That's the work of the CPU fan. Now that's what the heat sink, right? Now on top of the heat sink, we have a fan, the CPU fan. Now, because the heat sink is absorbing the heat coming out from what? Coming out from the processor, right? Which means the heat sink also has to be hot itself. So that's why there has to be a fan, CPU fan that will cool the heat sink that will have here right now. Right? So this is just the typical example, right? Okay. So we also have another form of we also have another form too, which we call the sorry, okay, here we are. So we move forward a little bit. Let's go back to slide 8. Okay, good. So liquid cooling system. So you can have some internal systems like this or internal system like this. So motherboard they have this kind of position. Those are industrial systems whereby you have all this kind of water loops, tube pump, so that goes to the see goes to the processor, kind of cool the system from prevent from getting hot. So you have this one, but in most cases in a normal in a normal computer, a normal PC, you hardly see this, right? You are going to see this. These are more of industrial systems. So you're going to see industrial systems, they are like this, right? So in most of our computer system, when you open it, you're not going to see this. What you see is the previous one, the motherboard and the CPU fan that we're going to see. So, but for knowledge sake, it's good that you just know about this, right? So for this kind of system, you're going to see cooling fan, you're going to see like this thing, you're going to see wires, cables, you're going to see like water that trying to cool the system when the system is working. So that is what this one is about, right? Okay, okay, that's fine. Okay, so now that's all for lesson 1, right? So let's look at lesson 2. So this is lesson 2 now. Select and install storage devices. So let's see how we can finish lesson 2. Now, select and install storage devices. Lesson 2. Okay, good. So yes. So now storage devices we explained the other day. They are hard drives. That where we store. That where we store. That where we store our information, right? So back then we used to have what we call floppy drives, but they are now obsolete. Floppy drives are just like small. You can store some. So we have 5.3, 3.5. Those are drives. They are obsolete. So but let's look at the day. Today now what we have is you have the internal storage, which is hard drives, or external storage, which is what external hard drive. We also have what USB drive, flash drives. All these are form of storage, right? So let's look at the internal storage. For the internal storage, just to connect to USB port and you're good to go, right? Just connect it to the USB port, you're good to go. Now, for the internal storage, the system itself, the system itself has the system itself has the system itself has a bay, storage bay like this. See, optical bay drive. See, they have this for the standard storage. So the standard storage are the hard drives that you connect to the motherboard. So for that, you're going to have those bays here where you have the hard drive, you slot it inside. In lesson 1, we showed you the hard drives, right? In lesson 1. Then you slot it inside. When you slot it inside, you need data cable, which we explained to also in lesson 1. The data cable to connect the hard drive to the motherboard. They need a power cable to that will connect what that will supply what the hard drive power. Because without power, the hard drive is going to function. Because the hard drive need power. If you connect data cable without power, it's not going to work. So you must go to supply power. So these are the base. These are where you connect your hard drive. See, this obsolete. These are the um, floppy drives. Floppy drive. You can Google it and see floppy drives. They are obsolete. They are obsolete now. They no more. They no longer exist now. Okay, good. So now, so you can have this type of these are kind of hard drive. See, SSD hard drive, right? So you have this. These are how hard drives look like as internal hard drives. Example like this. You have these solid. We call them solid state drive. So you can have your hard drives like this. So you can see typical example of the hard drive. These are solid state drive. You know, yes, the interfaces, you have SATA, serial SATA, and the M SATA. So these are M SATA, right? So this kind of hard drive, you can see them with your motherboards, with your the ghost internal, right? So you could have them with your external hard drive too as well. They are like this. Then you could have this also. All these are form of hard drives, right? So interfaces. So we have the serial SATA, then the M SATA, which is like this. Then we have a PCI adapter card. So the PCI card, which we also explain, PCI Express, this card, the PCI Express card, which is your PCIe, is those slots. To explain that, those slots that you can connect external device to. So you connect to the motherboard. For instance, now let me just show you something. So take a look now. Now I see these are the slots we're talking about. All these are slots. These are PCI slots. See all these ones. All these are PCI slots. If, for instance, now you want to connect an external hard drive, right? External one, you can use this card to do that. That PCI. Call this one. See this and this two. So I advise you also to take a look at lesson one. We explain all this in lesson one, right? So that is for that. Okay, so now your hard drive, this is a typical hard drive, typical hard disk drive. So these are your hard disk drive. Is internally when you open it like this. So internally your hard disk drive is like this. When you open it, it's definitely like this. It's going to be like this, right? So all those things you really don't need to bother so much about this. You don't need to bother so much about them. In your A plus exam, you're not going to ask questions like this. I'm telling you. So you don't have to bother. Just know that the hard drive is like this. When you open it, you have this part of it that you used to read and write it. They have the window. They have this one is the plates, right? This is the equator. So we don't need to bother about these ones, right? So let's move to the next slide. Okay. So very important is our hard drives. Very, very important is our hard drives, right? So we have different kind of storage devices, right? So what we have here now, we have what we call independent array of what? Independent, this can called read drives. Some of you are what about the aware of read drives, right? So we have with 0, we have with 1, we have with 3, we have with 5, we have with 10. So your RAID drives, they are very important. So what they do is to provide fault tolerance. So on top about fault tolerance is the ability of the system to be able to recover when it's default. That's called fault tolerance. Again, the ability of the system to be able to recover when it's default. If they had this developing faults, will you lose the hard drive? You understand? Will you lose the storage information inside? Will that be a disruption in the operation? With fault tolerance to ensure that the system can still be able to work even if there is a failure. So the able to recover and still able to work. That's what fault tolerance is, right? So in fault tolerance, we have RAID drives, which we will explain as well. Independence array of disks. So again, it's called redundant array of disks. So we call it RAID drives. Okay, so we have different type right now, right? So we have RAID 0, we have RAID 1. So we talk about RAID 0, we talk about RAID 1, RAID 2, up to RAID 5. Then we also have the mirroring of hard drive 2, the mirroring of hard drive, right? So if you take a look at what we have, then we have two hard drives here, two of same hard drive, right? So take a look at these two here. They are the same hard drive with same size. Take a look. You see, no disk, no disk, no disk. Failed. This read. This one is not there. This one is showing. So in this kind of scenario, which we're going to explain very soon, it's called read one. See read one, which is mirroring. So read one means you have two same hard drive, two similar hard drive of same manufacturer and same size. Look at it, they have two sides. So now in this case now, if this hard drive is not connected, this one is missing, this one fails. So you have two hard drive installed, one fails, which means you can use the second one for say to recover. So this one can when it's not fail, this one can recover. So in a mirror drive, whatever is on this hard drive, this one on this second one. So so when this one fails, the first one fails, you just have to what recover what activate the second hard drive, which is the second hard drive, and once you activate it, start working. Then later on, once you get a new hard drive, this same type, this same kind of hard drive, you can now replace this on then continue your read one. Okay. Okay, so let's take a look at the various kind of reads. So here we have read 1 and read 0. So if you take a look right now, if you see what we have here right now, you notice that we have this one's called read 0 and this is called what read 1. So read 1, read 0 typically they provide what no fault tolerance. No fault tolerance. We explain fault tolerance right now. We say fault tolerance is the ability of the system, the hard drive to be able to recover when it's a failure. That's fault tolerance, right? So read 0 provide no fault tolerance, but it's very fast. So with one, you can use read one to have you can have multiple hard drives in read one, multiple hard drive like between like you see now. See all these are from two hard drives. See two hard drives. Inside the hard drive, you have data stored, partitioned different ways. Right? That's read one. That's read zero. So for read zero, you can have one hard drive, one system contains more than two hard drives. So more than two can partake in that read. That's read zero. But what they provide what is very fast, very fast, very fast, and you can use for situation like for gaming and where you have mass information storage, you can use it there. But what when one of the hard drive goes bad, all the hard drives is gone. So it doesn't provide for tolerance. Therefore, read one, we call it one mirroring. We call it mirroring. So you just what you just need to just two hard drive there, two. Just have your two hard drives there. You have two hard drive, one data, one like unlike this one. I have several multiple hard drives that are connected. Here we have two. See, take a look at two hard drive. So what happened is that say only 50% disk available to volume. So in this place here now, right? If you are doing mirroring, what it means is that if you create a mirror, right, one side of it is used for what storage. That is half of it for storage. The other side is for what? Disk redundancy. So in other words, your full hard drive, the other is 100 gigabytes. That 100 gigabytes is divided into two. 50 we use for what? Volume. See, only 50% disk capacity available to volume, while the rest is for the mirroring. So if one fails now, if one of the hard drive fails, you will still have fault tolerance. So what happens is that the one that fails, you just try to get a new hard drive and slot it in. Then when you slot it in, then you can reactivate it. The system will not continue working. So you're not losing your information. All right? Okay. So that is with one. Then come we have with five and with 10 too. With five and with 10. So with five is before with 10 came in, with five has been the most effective fault tolerance that they use with five. So for with five, you're gonna have you know with five is the same thing it's also the same with storage with zero, right? Where you have multiple hard drive participating, multiple hard drives, like you see now. So multiple hard drive participating in the read. But right now, but you know, you have multiple hard drive participating, and it also provide fault tolerance, unlike with zero that does not provide fault tolerance. So you have multiple hard drive participating in the read, provide fault tolerance. So it means that if one of the hard drive fails, right, the system will not be disrupted. Operations will continue, system keep working until you replace the 41, right? When you place 41, still the system will not be, will still not go off, still be working. Now, what happened is that if we have all these hard drives and one of the hard drives one of the hard drive here fails, so you have five hard drives, one of them fails inside. So what happened is the system is still working right now. So what you have to do is to get a new hard drive and slot it in by doing what called hot swapping. So you don't need to shut down the system. Hot swapping means while system is working, you can bring new hard drive and insert it. Automatically, it will be adjusted. System will see it and configure it to the RAID. So that is RAID 5. So RAID 5 again provides what more than 2, 3 hard drives. You understand? Up to 5 and provide fault tolerance. RAID 0 does not provide fault tolerance, but it can take most up to 5 hard drives. But what RAID 0 would provide faster, this makes system work faster and can give larger storage. RAID 10 is similar to what RAID 1, which is mirroring, similar to mirroring 2. But the difference between RAID 10 and the mirroring RAID 1 is that what in mirroring you just have 2 hard drives, right? But in RAID 10, you can have up to 10 hard drives, 10. Sorry, up to 4 hard drives participating in that 10. Similarly to just like we said in RAID 1, you use 50% capacity. The same thing also in RAID 10 too. So RAID 10 use 50% of your entire storage. So it's split to 50% for volume, 50% for the read. So the same thing we explain about mirroring, which is with one. If one of the hard drive goes bad, system still keep working. All you have to do is just take up the 41, insert a new one, and the system keep working. So that's what about our read, right? So this is about our read drives, and so these are the next thing we have. We have the removable storage drives. So these are disk enclosure, right? See, portable hard drive. So some of you have seen the external hard drive. They're like this. So this is just a casing to cover it. That we call disk enclosure. This is a disk enclosure, right? So typically we have this one. So we are used to these. These are memory cards. These are memory cards. These days you see them for your phone. You can have, these are memory cards too, right? Then the most one we are used to is flash drives. These are flash drives that we use, right? So all these are forms of. Okay, so this is optical drive is obsolete. CD-ROM drive, you don't see it anymore. We talk about it in lesson one. They are obsolete. You hardly see them. They're out of stock right now, right? Okay, so this is it. We're going to stop here for lesson one and lesson two. So we're able to take lesson one and lesson two today. Okay, this is good. So we are stopping here. In our next video, we're going to look at what lesson two lesson 2C, right? So we're going we again we are stopping here for now. So we finished lesson 1 and B, lesson 2, 1 and B, right? 1A and 1B. So in our next video, we're going to look at lesson 2C, install and configure system memory. So take care. I'll see you in lesson 2. So I'll see you in lesson 2C. Take care. Bye.